All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of my never-ending quest to try to make life easier for students in the AWD 1000 Web Development Technologies and AWD 1111 Database-Driven Web Development classes, I've been doing a series of video presentations that I based off of some of the ebooks from Mr. Flavio Copes. And as you can see, on the screen. He's got several of them. He's actually got, I believe it's 14 different ebooks. Now, as far as those ebooks go, I'm doing presentations based on 7 of the 14 ebooks. So far, I've done a series of videos or video presentations on the HTML ebook, the CSS ebook, the JavaScript ebook, the ES5 to ES Next ebook, and the React ebook. I'm in the middle right now of the 6 of 7 I'm going to do, and that's the Node.js ebook. As you can see, if you take a look at it, this ebook is 189 pages, and I'm not even halfway through. And it's time that we come in here and we talk about the event loop. And as it says, the event loop is one of the most important aspects to understand about JavaScript. All right. The author says here he's programmed for years with JavaScript, yet never fully understood how things work under the hood. All right. It says it's completely fine to not know this in detail, but having at least a minimal understanding will probably help. So that's what this particular part of this document is about. Okay. Now, JavaScript code, as it says, runs single-threaded. Technically, only one thing can happen at a time. Now, as they mention here, you may consider that to be a limitation. But that said, it's actually pretty much a good thing because it simplifies the way that you work, and you don't have to worry so much about concurrency issues. In other words, you know, if two people or two things are trying to happen at the same time, which one wins type of thing. It says you just need to pay attention to how you write your code and avoid things that could block the thread, like synchronous network calls or infinite loops. In general, in most browsers, there is an event loop for every browser tab to make every process isolated and avoid a web page with infinite loops or heavy processing. The environment manages multiple concurrent loops. For example, web workers run in their own loop as well. If you want more on that, you can take a look right here and see this article that Copes has on web workers. All right. It says you mainly need to be concerned that your code will run on a single event loop and write code that will keep this loop from blocking. All right. Now, as mentioned here, any JavaScript code that takes too long to return back control to the event loop will block the execution of any JavaScript code on the page, even block the UI thread. So in other words, you're kind of stuck on the page. You can't do much of anything. You can't click a button. You can't hit the back button. Nothing will work. Now, the good news is, as mentioned here, almost all of the input, output, or I/O primitives in JavaScript are non-blocking. All right, so blocking is the exception rather than the rule. All right. So the call stack is something that's referred to as LIFO. And LIFO, the way this has always been explained to me is imagine that you go into a cafeteria and the cafeteria worker comes in and he or she has got a bunch of trays with them. And they grab those trays and they put them on that machine where it's kind of like a spring thing and you push down. Well, you walk by and let's just pretend all the trays are clean. I don't want to hear any jokes about there being a dirty tray, but you grab the top one. So the last tray that was put in is the first one that will be removed. That's the way the call stack works. So as it says, the event loop continuously checks the call stack to see if there's any function that needs to run. It says while doing so, it adds any function call it finds to the call stack. And there'll be a lot of pictures of this that will show it. And it's probably worth your while to at least trace through those yourselves to make sure that hopefully it makes sense to you. So the idea here is it says, okay, imagine that you're running your program and you call foo. And what does foo do? Well, foo does a console log with the word foo. Then it calls bar. Notice bar says throw a new DOM exception, and that's what happens there. Then it says call baz. All right, and you notice that you've got foo, but you never got baz. Well, typically when it throws an exception like this, all right, you're kind of dead in the water. There's not much more you can do. You've thrown an exception. And if you don't handle it, the program will end. So let's take a look at this example. Now notice it's different. We call foo, which should log out foo, then call bar, which should log out bar, and then call baz, which should log out baz. So if this works the way I think it would, you will have in your JavaScript console foo, bar, baz. And as it says, that's what you'd expect. So when the code runs, let's look pictorially at what's happening here. First, foo is called, and then as it says, inside of foo, you call bar, and then we call baz. All right, so it says at this point, the stack is going to look like this. The event loop on every iteration looks to see if there's something on the call stack, and if there is, it executes it. So it sees foo is there. So what does it do? Okay, it goes and executes that line. Then it sees, oh, now you're calling bar. So it basically gives up control and it calls bar. Then it comes back again. So these two are on the call stack. Then it could pop that one off because it's done, but there's still a call here to baz. So it calls baz, comes back, there's nothing else there, so it pops it off. There's nothing else there, so it pops it off. As it says here, the event loop on every iteration looks if there's something in the call stack and it executes it. So this is what's happening as it's working its way through. Foo, calls bar, logs bar, calls baz, logs baz. And it keeps doing this stuff until the stack is empty. All right. It says the above example looks normal. There's nothing special about it. JavaScript finds things to execute and does them in order. And that is the way that it works. Now, when it differs is when you want to change the way the execution works. All right. So it says, let's see how to defer execution until the stack is clear. Now, it's interesting here because we're doing a set timeout. And even though we're doing it for 0 seconds, what I believe is going to happen here is it's going to call foo, it's going to console log foo, and then it's going to do a set timeout. All right, and when that timeout ends, it's going to call baz. So it says here, you might be surprised to see what prints out. Foo, but then we've got the timeout before it calls bar, but it calls baz in the meantime while it's waiting. So we get foo, baz, bar, even though that timeout was set to 0 seconds. As it says, when the code runs, first foo is called. Inside foo rather, we first call the set timeout. All right, then we call baz. So the stack is going to look a little bit different. See, when we got the set timeout, basically it's going to take that and it's going to say, oh, we've got to wait for a while. So it gives control back so it can call baz, do its thing. Now there's nothing else to do in here, so it can call bar. All right, so again, they show the execution for this. Nothing is happening. All right. Here, this is not printing out. So it doesn't say foo bar baz. Again, it says foo baz bar because we put the timeout in there. I know the words they use in here are a little different for lack of better words. When set timeout is called, as it says, in this case, if we're using Node.js, we're going to set, well, either way, we're going to set a timer. Once the timer expires, which in this case is immediate, this callback function is put back on the message queue. But in the meantime, the system has moved on. All right. And that message queue, as it says, it's also where user initiated events like click and keyboard or fetch responses are queued. This becomes important. All right. Because when you put pauses in there, for lack of better words, you can tell the system, hey, I want you to do something, but while you're doing it, I want you to go on and do something else. So as they mention here, the loop gives priority to the call stack. It first processes everything it finds in the call stack, and once there's nothing left in there, then it goes back and it picks up things that are in the event queue. So as it says, we don't have to wait for functions like set timeout to do their work because they're provided by the browser. It says, for example, if you set timeout to 2 seconds, you don't have to wait 2 seconds right there. The wait happens elsewhere. All right. So about 6 years ago, as mentioned right here, ECMAScript 2015 introduced the concept of the job queue. The job queue, as mentioned there, is also used by promises. It's a way to execute the result of an asynchronous function as soon as possible rather than being put out to the end of the stack. All right, promises, as it says, that resolve before the current function ends will be executed right after the current function. That's the key part, right after the current function. And the author uses an analogy here. Draw your own conclusions as to whether or not it's a good analogy. The author says, I find a nice analogy of a roller coaster ride at an amusement park. The message queue puts you back in the queue with all the other people that are in the queue. Now, a queue, unlike a stack, a queue is first in, first out. So while the job queue is the fast pass ticket that lets you take another ride as soon as you finish the previous one. So again, we've got this. We log this out. Okay, we do this. Now we're setting a new promise. Okay, so as it says, we should be able to go on and it does foo, then it waits, then it calls baz, which is going to print out baz. I'm sorry. Yeah. Then when this has been resolved, it's going to call bar, which should print out bar. So this should say foo baz bar. I'm sorry. Foo should be right after baz, but before bar. Bar. So foo baz. So it calls this. Then it says, oh, we got a timeout here. But as it says, this is the resolve. So it shows this first. Should be right after baz, but before bar. So then it calls baz, gives up control, comes back. Now this has been resolved. So then it's going to come in and the timeout's been done. So it calls bar. So it's foo, should be right after baz, but before bar, baz, bar. Guess I was wrong. Foo, baz. So it does this, then it does this, then it does this, then it does this. So try it again. Foo, then baz, then should be right after that, but before bar, then bar. All right. It says there's a big difference between promises and async await. And remember, async await was built to hopefully overcome some of the shortcomings of promises. All right. There's a big difference between that and plain old asynchronous functions that fall through with timeouts. Now that's a little bit confusing. And let's add to a little bit to the confusion by talking about this next tick. It says here, as you try to understand the Node.js event loop An important part of this is the process.next tick. Every time the event loop takes a full loop or a full trip, we call it a tick. It says when we pass a function to process.next tick, we're instructing the engine to invoke the function at the end of the current operation before the next event loop starts. So it says here the event loop is busy processing the current function code. When this function ends, the JavaScript engine runs all the functions past the next tick during the operation. This is how we can tell the JavaScript engine to process a function asynchronously. Calling setTimeout with 0 will execute a function in the next tick, much later than when using next tick. So you use next tick when you want to make sure the next event loop iteration that the code that you need has already been executed. Now, when you want to execute some piece of code asynchronously, but as mentioned there, as soon as possible, one way you can do this is to call setImmediate. Any function passed with setImmediate is a callback that's executed in the next iteration of the event loop. So as they say here, a function passed in process.nextTick is going to be executed on the current iteration after the current operation ends, which means we'll always execute before any setTimeout and before any setImmediate. All right. We are at just about 17 minutes. This seems like it would be a pretty good place to stop before we go into full-fledged timer mode.